Welcome, class. We got the shortest notes so far this year today because we are also going to do a worksheet afterwards. All right, so same day notes and worksheet for this section. So today we're looking at similar polygons. First, we got our warm up. Number one, we need to solve this proportion. So remembering back to doing this when we were looking at similar triangles before. Now we're just doing the same thing with polygons. So all you have to do is cross multiply. So 72x is equal to 6 times 84, which is 504. And we divide by 72 on both sides. Cancels on the left. And we're just left with x equal, and 504 divided by 72 is 7. So there's our first one. Second one, we're going to, again, cross multiply. 4x times 57 is going to get us a 228x. And 19 times 39 is going to get us a 741. And we divide by 228 on both sides. And here we are going to get a decimal, but it nicely rounds, and it's 3.25. Doesn't round, it ends. Nice and even fraction, or decimal. So no crazy extensions, no need to round. So now we're going to cross multiply on the last one. Now we got a couple equations in the numerators for our fractions. So 8 times 2x minus 1 equal to 4 times x plus 4. I'm going to distribute the 8 inside and the 4 inside. So 8 times 2 is 16x. 8 times negative 1 is negative 8. 4 times x is just 4x, and 4 times 4 is 16. We're going to subtract 4x from both sides. So it cancels there. 16 minus 4 is 12x, minus 8 equal to 16. Going to add 8 to both sides. So now we have 12x equal to 24. We divide by 12. And our x comes out to be 2. Okay? So let's get into these notes. We don't have a lot to get through, but again, we have a worksheet to do after this. So vocab, similar polygons, we got scale factor, and that's it. So here's our similar polygons notes. Really like to focus on the first sentence there. Two polygons are similar if and only if their corresponding angles are congruent and corresponding side lengths are proportional. So corresponding angles is shown there, corresponding sides are proportional, so you can just set up a bunch of proportions for that. So sides that should be similar to other sides that's similar. And corresponding angles are the angles that match up that are congruent. So here we have two polygons, but really it's two triangles, right? So remembering back to doing this before, we have two triangles. We want to show that, or list out all the, we know that they're similar. We want to list out all the congruent angles and a proportion that relates to the corresponding sides. So for the angles, it's pretty easy. So angle A is congruent to angle R. It's in the same location. Angle B is congruent to angle S. Again, same location. And angle C congruent to angle T. So there's our three angle congruent statements. The last one is the proportion. So we're going to do side AB would be over side RS. Side BC over side ST. And then side A or CA over side TR. and that's it. We don't know anything else about it. We can't plug in any numbers. We don't know the numbers that are going on here, so we can't say that it's proportional by some factor. We don't know the scale because we don't have numbers. So here's our next one. Tan is designing a new menu for the restaurant where he works. We want you to determine whether the size of the new menu is similar to the original menu, and if so, we're going to write a statement and find the scale factor. So what we're going to do is we're given two proportions for each of these. We're going to set up a proportion, and if the two proportions are not equal, then they are not similar. So 10, the side for the top part for the original menu. The new menu, same location as the top, which is 12. 10 over 12 simplifies to be 5/6, which in decimal, just in case you want to see it, is 0.833 repeating. Then we look at the other two sides. We got 12 for the original, and then 14 for the new one. 12 over 14 simplifies to be 6/7, which is 0.857. So they're not the same, so not similar. Because those two numbers are not the same. If they were the same exact number, we'd be good and they would be proportional. Here again, same idea, different menu for the second one, or the new menu. So we're going to do the exact same process. So now instead of 10 over 12, it's going to be 10 over 8, which instead of simplifying down, I mean we can, but this one is 5/4, but we still need the decimal. It's 1.25, and perfectly 1.25. We do the 12 over 9.6. Now we can't really simplify down because unless you know some things with decimals here, you won't know how to simplify that. So we'll just get this in decimal, and it does come out to be 1.25 as well. So let's check. That means these are similar. Okay, so now we are given that these two polygons are similar. We want to find x. So to do that, we're going to set up proportions and solve for x. So we know two sides that are in the same spot, the 6 for line AB, or segment AB, and we know that 4 for segment RS, they're in the same spot. So we're going to set those two equal to each other, or not equal to, we're going to set a proportion with that, so 4/6. We're going to do the same order for the other fraction. So TU is 3, X is where CD is. So 3/X. Cross multiply like we did on the warm-up. 4X is equal to 3 times 6 is 18. And then we divide by 4. And X comes out to be 4.5. Okay, so now we're going to do the same thing to find y on those same figures. So y is at the bottom with +1. So same process, we're going to start with the 4/6 again. This is going to be equal to, now the y plus 1 is going to be on the top, and this 8 at the bottom of the polygon ABCDE is our same position. Cross multiply, 6 times y plus 1 equal to 4 times 8 is 32. I'm going to distribute the 6, so we got 6 times y is 6y, 6 times 1 is 6, equal to 32. Subtract 6 from both sides. 6y is equal to 26, and we divide by 6, and y is equal to, we can just leave this as a fraction, 13/3, or 4.33 repeating. Either way, I take that. Depends on if it's multiple choice, it'll give you whether you want it in decimal or fraction. So. Here we have perimeters of similar figures. So same idea. The perimeter of a similar figure, or similar polygon, sorry, will also be that same factor. So whatever the scale factor is for the sides goes along with the perimeter of the polygon as well. So we're going to use that here. We have some equal sides, so let's go ahead and label all these things that are equal so we know what we do have in total. It looks like we only have 2 sides for each one. Really, we have 4 sides for each one. Well, 4 sides for one of them. We have 3 sides for the other. So I went through, labeled them all on the right side and the left. They're the 4 at the top. So now what we need to do is set up some proportions to solve for the other parts we don't know. So let's do, we got the 4 and the 7s, we know we're in the same spots. So we'll use that as our factor. And we need that to be congruent or equal to 6 over the base of the other one we'll call ST. We'll just plug in as ST. So we're going to cross multiply 4 times ST. 7 times 6 is 42. When we divide by 4, ST comes out to be 10.5. So we got that ST is 10.5. That means it's congruent to those other 2 sides as well. And since we are similar here, that's the same thing that's going to happen with A, B, C, D, E as well. So the bottom is 6. These are also going to be 6. So now we have all the sides of all these figures. We can find the perimeter just by adding all the sides together. So 4 plus 6 is 10. We got 2 of those on A, B, C, D, E. So that's 20, and 20 plus 6 is 26. So P is equal to 26 here. And then the other one, we got 10.5 plus 10.5 plus 10.5, so that's 30 plus the 0.5 would be 31.5. And 31.5 plus 14 comes out to be 45.5. Okay, so that is it. Here's your exit ticket, and go ahead and work on the worksheet. Your exit ticket's here, and we will be taking notes tomorrow over some area problems, and that's it. We'll see you later.